Take a look at this request. Just a simple one-sentence message. We need a dev review system to handle code checks. It is incredibly tempting to grab that single sentence, feed it into an AI coding agent, and watch the application architecture instantly spin up. The resulting code might compile flawlessly, but because the prompt didn't specify load constraints, security protocols, or audit needs, the agent has no reason to include them in the build. If you only capture top-level features, you build massive blind spots directly into the product. Important quality expectations and business details get completely ignored. To prevent generating fast, incorrect code, a developer has to stop acting as a passive order taker. You have to actively interrogate the requirements first. Let's look at the business requirements section of our documentation framework. The questions here force us to explicitly define why we are building this system in the first place. For our dev review system, the underlying value is specific. We need to reduce the manual effort of code reviews and help developers catch issues before the founder ever has to look at them. From there, we shift to the user's perspective. The user requirements establish who is operating the tool. In this case, a developer, who needs to see review issues grouped by severity so they can tackle the critical bugs first. Only now do we define the functional requirements. These dictate the precise behavioral rules, like letting a user create, edit, assign, and update the status of a task. By establishing the why, the who, and the what, we transform a vague idea into a specific behavioral model. But it still doesn't tell us how this system will survive in a real-world environment. That brings us to this list of non-functional requirements. These questions define strict performance benchmarks, like ensuring the dashboard loads within an acceptable time for internal team usage. Then we detail the UX requirements to handle edge cases. When no tasks exist, a user shouldn't hit a blank, broken-looking page. They need a helpful empty state explaining how to create their first task. Next are the data requirements. We explicitly outline what data entities exist, what relationships they have, and what history needs to be searchable. To prevent weak database and API design down the line, we list out the exact fields. Every task must store a title, description, status, owner, priority, and activity history. Mapping out user experience edge cases and database architecture creates a system designed for the unpredictability of actual human usage. Look at this central node representing our dev review system. To be useful, it has to establish integration requirements. We define exactly how it connects and moves data with existing planning documentation tools. We also set strict security and permission requirements. Sensitive actions, like granting app access to new team members, are isolated and restricted strictly to admins. If we use artificial intelligence, we must consult our AI and agentic requirements, shown here. The critical rule is defining boundaries. An AI might suggest QA test cases, but it can never be allowed to approve them without human validation. Finally, we check the operational requirements. This gives us the survival protocols for deployment, mapping out required environment variables and database migration steps. Defining external connections, AI boundaries, and operational environments provides the specific roadmap needed to deploy and maintain the code in a production environment. To know when the job is actually done, we consult the acceptance requirements, shown here. These connect the requested functionality directly to verification, proving that specific conditions actually pass. And to prevent overbuilding, we look at the out-of-scope requirements. By intentionally documenting that a feature like AI-based sprint planning is excluded right now, we prevent agent drift. Look at the difference. We started with a vague request on the left. On the right, we have a comprehensive set of requirements that address every layer of the software lifecycle. As this summary list shows, ignoring non-functional details or treating requirements as a flat feature list are common traps that lead directly to broken products. Before you write a single line of code, and before you write your first prompt for an AI agent, you have to pause and run this exact interrogation framework. True full-stack engineering is measured by how completely you understand the problem you are solving, well before you ever touch the keyboard.